One of the best ways to develop strength in the water is heavy, fast, resisted swimming. But when done well, it doesn't just develop physical strength and power, it develops skill as well. Hi everyone, Andrew here, helping you help your swimmers get faster. To go fast, swimmers need to create as little resistance as possible and as much propulsion as possible. So the more propulsion that they can create, the faster they're going to go. Intuitively, coaches navigate towards heavy resisted swimming to develop the strength necessary to create a lot of propulsion. It's a strategy that works. It's a strategy that we can make more effective by not only helping swimmers learn how to create more propulsion in terms of the force that they can create, but if we can help them learn how to apply those forces more effectively, they're going to go even faster. Let's take a look at how to make it happen. A huge component of swimming fast is horsepower. The more propulsion swimmers can create, the more speed they're going to be able to create as well. There are two aspects to creating a lot of propulsion. One, swimmers have to be able to produce a lot of force in order to move the body forward, but they also have to apply those forces effectively to move the body forward. So if swimmers are applying a ton of force, but that force is going straight down, that might lift swimmers up higher in the water, but that's not necessarily going to move them forward down the pool. Or if the forces are moving laterally, again, that's not going to move swimmers forward. So applying those forces really matters. But even if swimmers are applying their forces with absolute precision, if they're only capable of creating small amounts of force, they're not going to swim very fast as well. So swimmers need to have a lot of strength specific to what they can create in the water, and they have to have a lot of skill. The importance of creating a lot of propulsion is fairly obvious with sprinters. The shorter the distance are, the more the maximums matter. So the maximum amount of force that they can create and the maximum efficiency of force application. However, the higher the maximums are, the easier it is to maintain a submaximal output. So being able to create a lot of propulsion is also really important for distance swimmers because the higher those levels are, the easier it is to maintain any other output. For instance, it's a lot easier to go 58.0, which is world record pace for 1,500 meters, if someone's best time is 48, as opposed to if their best time was 55. So the more propulsion swimmers can create, it improves their endurance as well. So for every swimmer, it matters. So how can we help swimmers create a ton of propulsion? How can we lift the maximum level of propulsion that they can create? We can use power-resisted swimming. So what that is resisted swimming with higher loads, with higher speeds, with shorter distances, and with a lot more rest. So if we can put swimmers in situations where they have to create a lot of force and they have to apply forces effectively, they're going to learn how to do both better. From a force production standpoint, they have to create a lot of force in small amounts of time because that's the only way they're going to overcome the resistance and move forward. They also have to learn the skill of moving as much water as possible, as fast as possible, because again, if they don't do that, they're not going to move themselves forward. So we're improving both the ability to create force and the ability to apply force effectively. So this strategy differs from other types of resisted swimming, mostly from a set design perspective. So the emphasis here is always doing on whatever is required to create situations where swimmers can create as much quality as possible. So that means short distances, short durations, so that they can execute at a really high level of output. It means high intensities, high speeds, and/or high loads. And it means long recoveries so that swimmers can get ready to execute at the same level again. It's not about just getting as much work done as possible. It's getting a lot of really high quality work done. So that's going to help swimmers learn how to create a lot of force and how to apply those forces really well. While power-resisted swimming is really effective in and of itself, we can make it even more effective by incorporating skill development into these sets. The simplest way to do that is through the use of performance goals. So in almost all cases, swimmers are going to be trying to swim as fast as they can. If we can add stroke count goals or stroke rate goals to those speed goals, we can help swimmers become even more efficient. So if they can only take a certain number of strokes and they're trying to go as fast as they can, they have to figure out how to get more out of each of those strokes. If they're only allowed to use a certain stroke rate, if they can't move their arms faster and they want to go faster, they have to figure out how to get more out of each stroke. So we're requiring swimmers to apply forces more effectively by limiting their stroke counts, by limiting their stroke rates. We can also add different sensory strategies. So we can use certain drills to challenge skills under pressure. So whatever stroke it is, you can use drills for that stroke that challenge swimmers to create more propulsion. And by adding the extra resistance, they're going to have to execute those drills better. And when we're using power-resisted swimming, they're going to have to do so with really high levels of force and really great force application. We can also use training aids to emphasize specific skills. As a simple example, you put a buoy on someone, they're not going to be able to use their legs very much. You have them use a kickboard, they're not going to be able to use their arms. So by using different training aids, we're emphasizing different aspects of the skill. We can also use hand postures. So by closing the fist, having them hold paddles upside down, we can also encourage more effective arm actions when they're swimming against really high loads at really high speed. So by incorporating skill development, we're going to continue to get great force production. We're also going to get great force application as well. So here's a set that puts these ideas into practice. They're going to go 3 rounds through. They're going to go 6 times, 10 breaststroke kicks with a board and a heavy parachute, so a lot of load. The odds, they're trying to get as far as they can in those 10 kicks, so they've got to move a lot of water with each kick, working against the resistance. The evens, they're trying to go as fast as possible, so now they're creating speed against that resistance as well. Then they're going to go a 25 breaststroke with a medium parachute, minimize stroke count and time. Again, they're going to have to use the legs well there to stay long and go fast. Then we're going 25 breaststroke with a medium parachute straight up fast. Hopefully they can still execute a great kick. And then a 25 breaststroke fast without any resistance. So we're putting a lot of pressure on the legs here. We're asking swimmers to create a lot of propulsion to overcome the load, and they have to do that primarily with their legs. By giving them stroke count goals, by asking them to go as far as they can with the kicks, we're encouraging swimmers to not only kick hard, but to kick well. This set, we're going to challenge the upper body in backstroke. So they're going to go 4 rounds through. They're going to go 8 cycles backstroke, so 16 total strokes. They're trying to get as far as possible at a stroke rate that's relatively slow, 1.5 seconds per cycle, and they're doing that against a heavy pulley. So really any type of resistance will work here. We're using like the power towers or the destro towers, or even just a pulley system that's rigged up to the side of the pool. Doesn't really matter. It should be pretty heavy, and they're trying to get as far as they can at that stroke rate. So the stroke rate's the same. They can't slow their stroke rate down to try to get further. They have to get more out of each stroke in order to get further, because they only have 8 strokes. They can't slow the stroke rate down. They got to get more out of the strokes in order to get further. Then they're going to go 7 cycles. Now it's going to be a medium pulley, so less resistance at 1.4 seconds per cycle. They've got less resistance. They've got a faster stroke rate. They've got to figure out the same challenge. Then they're going to go 6 cycles as far as they can with a light pulley. Again, a faster stroke rate. And then they're going to go 25 backstroke fast at an even faster stroke rate, but they don't have any resistance. So they're working against the resistance, they're limited in their stroke rate, and they're trying to go as far as they can for the first 3, and they're just trying to go fast on the last one, and that's going to require them to get more out of each stroke to get further each time. One more twist is on the odd rounds, they're going to use a buoy, so they can't really use their legs very much. And on the evens, there's no buoy, so they're going to do that regular backstroke and put all the pieces together. So rather than just doing some heavy resisted swimming, we're adding these other components to get more skill development so swimmers can learn not only how to create a lot of force, but to apply forces more effectively. This set is a butterfly set, and we're going to use drag socks to put more pressure on the kick. So they're going to go 2 rounds through the whole thing. So the first piece, they're going to go 2 times 10 seconds as fast as they can. Dolphin kick with a board and drag socks, really working the legs. Then they're going to go 25 4 kicks 1 pull with drag socks. And now they got to execute the kick within the timing of the stroke. They're going minimize stroke count and time. So they're trying to swim as big as they can and as fast as they can. Then they're going 25 4 kicks 1 pull with drag socks, straight up fast. They'll repeat that section twice. Then they're going to move into regular butterfly. Again, 25 butterfly drag socks, minimize stroke count and time, 25 butterfly with drag socks fast, and then a 25 butterfly fast. So we're putting a lot of emphasis on the legs. We're putting emphasis on the kick timing, so the swimmers have to use their legs well. The drag socks is going to force them to really whip through their kick. And by using stroke count requirements, we're putting pressure on the ability to effectively use the legs, not just move them fast, but swimmers have to get as much as they can out of each kick as well. So a really great way to develop strength in the legs, but not only that, swimmers are going to learn how to use their legs more effectively so that they can create more speed. Having discussed how to use resisted swimming to create power and speed, check out the video below to see how you can use resisted swimming to help swimmers improve their endurance.